Hello, my name is Scott Mesjian, and today I'll be doing problem 59 for week 6 for discussion section 8. A diver 50 meters deep in 10 degrees Celsius freshwater exhales a 1.0 centimeter diameter bubble. What is the bubble's diameter just as it reaches the surface of the lake where the water temperature is 20 degrees Celsius? Hint, assume that the air bubble is always in thermal equilibrium with the surrounding water. So that just means the last part with the thermal equilibrium just means that we can assume that it increases in temperature with the water. Um, anyways, what do we know so far? So we know that at the top uh, of this water, the temperature will be 293 Kelvin. So we can write that as our T final. Um, we also know that at the beginning, the water temperature is 10 degrees Celsius, so we can write that as our T initial. Um, we also know that there's a change in 50 meters as the bubble goes up. Um, that will help for later. We also know that the diameter of the bubble is 1.0 centimeters or 0.01 meters. We can also write that in terms of radius. That would be an initial radius of 0.005 meters. The reason I change it to radius is because we'll be essentially needing to use the volume equation uh, and using radius to get the initial volume of the bubble. So if you do that, if you get the initial volume of the bubble, well, then we'll have initial volume as well. So far, if we have initial volume, initial temperature, final temperature, and okay, so now what else do we need? We need to solve for the final volume, we need a final pressure and an initial pressure. Well, we know that in general, the pressure right above sea level is 1.0 atmospheres. So if we just use that as our final pressure, we can actually use Bernoulli's equation to solve for the initial pressure. Um, Now, to do that, you'll essentially need this 50-meter value, um, the gravity, and um, the final pressure. Also, one thing that would be helpful in solving that would be the atmosphere to Pascal conversion. So there's that. Um, yeah, besides that, it's relatively simple, I say. Um, yeah, so now that we have all the necessary inputs, we can solve for our final volume. And once we do, you'll get a value of 3.17 times 10 to the negative 6, and that's in meters cubed. So now we're not quite done yet, because we need the final diameter. So let's solve for radius first using the volume equation. If we do that, we will get a final radius of 0.0091 meters, and finally converting that to diameter by doubling it, we get 0.018 meters. So nice, now we have the final diameter, and now we can look at if that's what we expected it to be. Um, in general, if we so take note that this is a higher value than our initial diameter. Also, we increased the temperature from initial to final. So increasing the temperature would also mean we'd have to increase the volume, so that makes sense. Additionally, we also, um, oh, I should tell you that the initial pressure was actually, it came out to 5.8 for atmospheres. So um, using that, we can see that obviously the pressure decreased by quite an amount. And that also makes sense because that would mean that the volume would also have to increase. So the fact that the final volume increased or diameter increased makes sense. Yeah, let me know if you have any questions in the peer reviews. Thank you.